Okay, let's talk about inverse functions for a second. So let's find the inverse of the function f of x equals 2 to the x. So if we start with y equals 2 to the x, we switch x and y. So to solve for y, it's just log base 2 of x. Just rewrite it in exponential form. So if f of x equals 2 to the x, then f inverse of x equals log base 2 of x. Okay, so let's look at domain and range. So in the original function, 2 to the x, the domain is all real numbers because x is an exponent, it can be anything it wants. The range, however, is 0 to infinity because there's no value of x that you can put in there to make the whole quantity negative. It's always going to be greater than 0. Also, there's no value of x that will make it 0. Now let's look at this inverse function. So first we'll take the domain. Okay. You cannot take the log of a negative number. So the domain is 0 to infinity, just positive numbers. The range, on the other hand, if you put in a fraction for x here, you'll get a negative number. If you put in a whole number for x here, you'll get a positive number. And if you put in 1, you'll get 0. So the range is all real numbers. So we should notice now that for the original function, the domain of the original function is the same as the range of the inverse, and the range of the original function is the same as the domain of the inverse. That's because, to find the inverse, we switched x and y, so it makes perfect sense that the domain and range would be flipped. Okay, let's graph, but first complete this table. You should be able to do both tables without a calculator. Okay, so we've got a bunch of points. So hopefully you're seeing that each set of points, the x and the y values are switched. In the original function, it's -2 1/4, and in the inverse function, it's 1/4 -2. And that's the case for all of these values. That's not a coincidence, that's because they're inverse functions. Now I'm going to, let's look at the graph of these functions. Okay, so I graph the functions, not very well, obviously. Our original function, y equals 2 to the x, is in green. Our inverse function, y equals log base 2 of x, is in red. So you notice that our original function has an asymptote at y equals 0, and our inverse function has an asymptote at x equals 0. Graphically, the inverses are reflections of each other across the line y equals x. So when you look at it, you should be able to kind of envision flipping it over the yellow line y equals x, and they're kind of mirror images of each other. So that's kind of the graphical interpretation of inverses, and I think that's pretty cool.